Hey there guys, today we want to prove that 288 divides 7 to the power of 21 minus 487. Now there are different ways to prove this, but in this video we're going to take a look at one of them. And now before we go on, consider subscribing and ring the bell to not miss my latest videos, and hit the like button if you find this video helpful. So first of all, let's say that this number is x, so we want to manipulate x in a way that we will be able to say that x is divisible by 288. So x is equal to 7 to the power of 21 minus 487. So first of all, let's replace 7 to the power of 21 with 7 times 7 to the power of 20. And let's break 487 into 7 and 480. Now we can go ahead and factor out a 7 out of these two. So we will have x equals 7 multiplied by 7 to the power of 20, which can be written as 7 squared to the power of 10, and then minus 1 minus 480. Now 7 squared is clearly 49. So we have this. Now, we can go ahead and factor out this part using the identity that states that a to the power of n minus 1 can be factored as a minus 1 times a to the power of n minus 1 plus a to the power of n minus 2 plus a to the power of n minus 3 plus so on and so forth plus a plus 1 if n is a natural number. So by applying this identity, x is going to be 7 multiplied by 49 minus 1 times the quantity 49 to the power of 9 plus 49 to the power of 8 plus plus 49 plus 1 and minus 480. Now, let's go ahead and talk about powers of 49. So, 49 to the power of 1 can be expressed as 7 squared. Now 7 squared can be expressed as 6 plus 1 all squared, which is equal to 36 plus 12 plus 1. Now we can factor out a 6 out of the first two terms, so we will have 6 times 6 plus 2 and then plus 1. 49 squared can be expressed as 7 to the power of 4, which equals to 6 plus 1 to the power of 4, which equals 6 to the power of 4 plus 4 times 6 cubed plus 6 times 6 squared plus 4 times 6 and plus 1. So we can factor out a 6 out of these terms. So we will have 6 times 6 cubed plus 4 times 6 squared plus 6 squared and then plus 4 and plus 1. Now, these two expressions have one thing in common, and that is that we have them in the form of 6 times some integer and then plus 1. In fact, we can say that 49 to the power of any natural number like n can be expressed as 6 times an integer like m and then plus 1. So n is a natural number, and m is an integer. And this can be easily proven by induction. So we know that 49 is congruent to 1 mod 6. And we can assume that 49 to the power of k is congruent to 1 mod 6. And then we can use these two to show that 49 to the power of k plus 1 is congruent to 1 mod 6. So this can be easily proven, but here I'm going to use this pattern for our expression, for this part of our expression. So we know that x is equal to 7 multiplied by 48 multiplied by 49 to the power of 9 plus 49 to the power of 8 plus plus 49 plus 1 and then minus 480. Now, if you use the pattern, x is going to be 7 multiplied by 48 and then multiplied by the quantity 6 times some integer, let's say m sub 9 plus 1 plus 6 times m sub 8 plus 1 plus plus 6 times m sub 1 plus 1 and then plus 1 and minus 480. Now we can factor out these 6's, so we will have 6 times m sub 9 plus m sub 8 plus m sub 7 plus so on and so forth, m sub 1, and we have 10 times 1, so it's going to be 10. And then we can go ahead and replace this sum with an integer like p. So x is going to be 7 times 48 times 6p plus 10 and then minus 480. Now notice that 480 and this term are both divisible by 48. So let's go ahead and pull out 48 to get 48 times 7 times 6p plus 10 and then minus 10, which simplifies to 48 times 42p and then plus 60. And now 42 and 60 are divisible by 6, so we can factor out a 6. And notice that 48 times 6 is 288. So we have this. And since this is equal to x, we can clearly say that 288 divides x, which is 7 to the power of 21 minus 487. Great. So we are done. Thank you for watching this video. Hit the like button if you find this video helpful, leave a comment, and subscribe for more. Hopefully, I will see you later. Goodbye for now.